I recently replaced my printer. I wanted to level up my 3D printing game and decided to buy a Bambu P1S. My Ender 3, even though it served me quite well, it started to show some flaws. But it's also my own mistake, I guess, since I've been abusing my poor Ender 3. But with the new Bambu printer, all of these issues just go away. Bambu really prides itself on being very easy to set up, and I have to give them that. The price to quality is amazing. I got it and I set it up in 1 to 2 hours, and it started putting out prints that are great. They are just amazing, there's nothing else to say about them, but it didn't really sit right. While I'm sweet talking a Bambu printer here right now, my Ender 3 has been sitting in a corner doing nothing. And I think that kind of sucks. I just don't want this printer to go to waste. Having a printer like this end up in a dump somewhere is just wasted potential. So after having watched a bunch of YouTube videos about Ender 3 upgrades, I knew it was possible to get my old printer back up to speed with the newest, the latest and greatest. So after about 5 hours of watching videos, I think I have somewhat of an idea that I want to do. The most expensive upgrades were taken from TheBuildBay. I wanted to move to a dual Z-axis extrusion and also change the hot end. I ended up comparing a lot of different extruders or hot ends and decided that the Sprite Pro extruder was the best fit for my case. It is still within the Creality ecosystem, and I really want to move to a direct drive extrusion. Together with all of the metal gears, this allows me to use this printer for a different purpose than my Bambu. Where my Bambu is reliable and very fast, I now want to print with a lot of different types of materials. For example, very flexible ones or very abrasive filaments. And for that I think like a direct drive extrusion just works way better. It would also mean it would be much easier to service. Now everything would be contained within the same extrusion net. So if anything would go wrong, I would just be able to take out the print head and then fix the issue that came to be. I also wanted a bed leveling probe, just to get some better first layers. From a video I saw that it really didn't matter what kind of probe that it would use, so just decided to go with a very mature BLTouch. While it's still a bit ugly, I think that's easily fixable with just a proper enclosure. From the video from Maxy Meanderings, I knew that I wanted to try out old hem couplings. It seemed like a very cheap solution with very great results, so I just decided to give it a try. For a lot of other upgrades, I took inspiration from Scott1. He has a YouTube channel in which he makes a lot of modding videos, and right now he also creates like his own kind of products. It's an amazing channel, you should check it out. But for this Ender upgrade, I really took some inspiration from his first 2 videos, since I think these were the most impactful for me. I started watching him right when the video came out, and from that point I really knew that I already wanted to do an upgrade. Scott mostly gave me inspiration for the non-electrical kind of upgrades, like a handlebar for putting the bed, cable clamps, a cable chain, drawer compartment, bed leveling screws, filament holder and an LCD cover. I also did some research myself. I have heard about Clipper, so I might want to give that a try. I come from an electronics oriented background, so I actually have some Raspberry Pis laying around that would otherwise also be collecting dust. I thought Clipper would be a nice way to get one of these out of my closet and put them to good use. This then also led me into looking for a better control board. In the modern day, 8-bit processors like there currently is in the Ender 3 don't really cut it anymore. I've read that improving the bitrate of your processor greatly improves print quality, since you can increase the resolution of your prints. In addition to that, it can also reduce the noise level, since the stepper motors could go into smaller increments which could reduce noise. So with that in mind, I thought upgrading the control board was a no-brainer. It also led me into browsing the website a bit longer, and I ended up finding another screen. The current LCD screen, while it works perfectly fine, just isn't really pretty anymore. So I just decided to give another screen a try as well. I also came across some camera modules, so we can just throw that in as well. And if we include a camera, maybe some light strip would also be very nice. Oh, and also now we are just throwing everything in, maybe some belt tensioners come in handy if I really want to experiment a lot with the printers. With this rough plan, I went shopping. Mostly stuff from AliExpress or Biggie Shop, which was the shop that led me down the rabbit hole of upgrading my control board and eventually all of the other kind of stuff. After some waiting, the components arrived. Well, they actually arrived a long time ago, but I only started working on this project and I decided to film it way later. So here's a reconstruction of the unboxing. Some components could also be printed. I searched websites if people had already made a lot of projects. While most were easy to find, I wasn't exactly happy with the current spool holders. I wanted one with no resistance, so I had to use bearings. I don't like most of the mounting methods, so I also created one of my own. So let's hop into Fusion and just show how the spool holder came to be. So we're back into Fusion, and even though it has been designed a while ago, I still wanted to go over the whole thought process of designing this piece. The whole piece was designed to slot into the top extrusion. So that's why you can see the V profile carved into the sides. The whole piece was also meant to be printed in 3 parts. You have the L shape, you have the supportive part, and then also the part with the bearings. If all parts are then printed, you would use bearings to press everything together. You also have one screw hole that holds most of the weight of the whole construction. Especially if a heavy spool is placed on the spool holder, it needs to be able to support this heavy weight. You can also see a bit of webbing. I don't think this actually is functional, I just thought it looked cool, so that's why I included it. Most of the stress is actually held up by the diagonal piece and the L shape itself. After having designed everything and downloaded the necessary files, I decided to put my new Bambu lab to good use. It started printing all of the things that I needed to upgrade my other printer. Kind of like an Inception kind of stuff going on here. After a couple grams of filament, I had everything complete. Dual Z-axis, old ham couplings, anti-backlash nuts, camera, BLTouch, belt tensioners, Sprite extruder, HDMI screen, SKR Mini E3, spool holder, cable chain, bed handlebar, and the drawer compartment. Yes, I know this isn't everything. Some of the things I mentioned I forgot to make from the beginning, but I decided to add later on. This might also be better. A lot of these components were already waiting around collecting dust, so it was time just to get going. All that was left to do was just to put everything together and figure out problems as they arose. So let's go, let's put everything together. To start, I basically had to undo all of the components. I was basically upgrading the entire printer, so it just makes sense to take everything off. I remember that assembling the Ender 3 wasn't difficult at all, so disassembling it also was pretty easy. So I started unscrewing everything without a clear goal in mind. This later came to shoot me back in the foot. If you decide to do this yourself, I would recommend to take a note of all of the screws that you take out and where to put them back in afterwards. Guessing where each screw goes afterwards isn't really fun to do. Also, keep in mind that this isn't a tutorial. I'm not showing everything that I've done, or I made mistakes that I just left in. Yeah, this printer has been sitting idle for a while. It has been collecting dust for over 2 years. At first I wanted to leave some components on, to save me some work, but after seeing all of the dust I decided to disassemble everything and do a proper cleaning of the device. When everything is complete, I can start assembling the printer again. This time with all of the upgrades. I first put back together the build plate. I could now install the newest bed leveling screws. It is the first touch of red that I added to the printer. The general theme was to go with a bit more red. I didn't like that it didn't have any color, and because red is spot on with the brand and these were the most popular screws, it was a no-brainer to go with these. They also have stiffer springs. These screws can help to achieve a better level bed and make precise movement way easier. Here's one of the first mistakes that I made. I wanted to add a handlebar, but I forgot to include it when installing the bed. So I had to undo all of the screws again and put it back together with the handlebar. Then it was time to install the belt tensioners. These are pretty straightforward to install. I was just to undo a screw, put in the belt, screw it back in, and then screw the tensioner to the gantry. After I undid the top part of the printer, I was able to take out the gantry. I now had to move over to my workbench. Over here I could install the spool holder and also install the lead screw holders. It was very straightforward and very fast, although I did make a mistake by putting the lead screw holders in the wrong slot. Next up was to do all of the existing couplings. These couplers aren't really great. They don't allow for any movement of the threaded rod. This movement is necessary to ensure good quality prints. That's why I bought the Oldham coupling. After undoing the lead screw coupler, I could screw it back into the Oldham coupling. I then also lubricated the entire coupler since there are a lot of moving parts, and after that I could screw it back into place. I also had to install the Oldham coupling on the other side, but in order to do that I first had to undo the mounting plate. The whole process of installing the Oldham coupling remains the same. The same goes for the other side. Even though I already installed the coupling, I still had to mount it to the gantry. When the gantry was complete, I could put it back on the ender, and after that I could reinstall the top part of the printer together with the spool holder. It was then time to install the Z-axis steppers. I had already prepared those, but the process for installing this one is the same for the stock Ender 3. It was then time to take off the old carriage. With the new extruder also comes a new carriage. So I opened the box, took it out, put it back on, and then it was time to install the Sprite extruder. Now it was time to do the annoying part, plugging in all of the annoying cables into the board. These cables are small, and routing them out to the cutout on the aluminum extrusion on the bottom was very annoying. At first I also didn't bother with cable routing. That was something to fix once I knew that everything ran fine. And then it was time to plug in the 2D printer. Alright, so I have a little bit of a problem. Basically, as you can see, I can go to motion and move the Z. Just do very small amounts right now. And basically, let me see if I can just focus on this coupler and that coupler. If I move it. Oh, so wait, let me give you a point of reference. Look at the two couplers. That one moves right, that one moves left. They're basically spinning in different directions. I don't think that's what you want. So I'm gonna try to fix. I've already done a bit of research, so what I'm gonna try to do is take this connector and just try to take out the little crimps and swap them around, and hopefully that would make this one spin in a different direction. So what I'm gonna try to do here is finesse the little crimps outside of its housing and then just move them around. The issue with these crimps is that they are very small, so I have to use tweezers to push them out, and I have to be very careful to not break anything. Luckily, this made them spin in the same direction, but the issue is that they're still moving in the wrong direction. I could fix this by doing the same procedure again on both of them, but because I've already done it on one, I don't trust myself to do it another time, since this could actually lead to the housing breaking, and I don't want that. So I have to do what I never wanted to do, and that's to fix this in firmware. You can actually see me sitting here in a bit of despair, because I didn't want to touch firmware for this project. But well, it left me no choice, so here I am in Visual Studio Code, trying to compile Marlin from scratch, sifting through all of the configuration settings just to get anything working. I tried to look up a reference configuration, but didn't really find much. So luckily ChatGPT managed to help with a lot of this, and for all of the things that ChatGPT cannot help with, I just searched forums or just read through the documentation myself. But unfortunately the documentation isn't always that great, but I still got through it, and over here you can see that it actually works. I have a custom name set and the firmware actually compiles, so that's pretty nice. And the plate is definitely heating up, that's good. And that should be about it. I just have to check if the directions on the screen correspond to the right direction of the carriage. And once that's complete and I've confirmed that everything works, I can try to get a print up and running. I just had to add some filament and see how everything went. So let's just load up a Benchy and start printing. So we have a failed print. But the first print failed. No big deal usually. you just start it back up and hope that the next one would be way better. It really is bound to happen that some mistakes creep into the process if you try to do everything at once. But this wasn't really a simple repair. I really didn't want anything to do with the printhead. I just wanted to put it on and hope that it worked. But after having pulled out the filament, put in new ones, the gears just didn't turn. They were skipping teeth, so I knew that something bad was going on. I had to take off the extruder and actually try to figure out what was going on. I found a video on how to take apart the extruder, so I did. Put it on my bench and opened everything up. And from the video you're gonna see it really wasn't a great experience. Alright, so I decided to do the repair off camera, taking apart the whole extruder. But I've just opened it and I can already see something. This is not good. Yeah, I thought I would just take the camera and just show it to you guys. This doesn't look very promising. This is the extruder part, by the way. Yeah. Fuck. Alright, so little update on the extruder. You can see that the filament just got fucking everywhere. It's literally inside of the entire thing. How is this possible that this could have happened? What the fuck? And one of these screws also fallen out. I don't... Wait, this one is supposed to be like this. It's like, oh, fucking hell. Well, I didn't know that this was possible to happen. Focus. This kind of sucks. At first, I didn't really think that it was worth filming the whole repair. But as you can see from the clip before, it was really worse than I thought. Having this much filament stuck in the extrusion head just doesn't really spell good news. I thought it was lost. And I didn't think that I could actually fix this issue, and I had to go do the old extrusion head again. But I just decided to give the repair a shot. I cleared everything, took out the filament, heated some parts up so the filament would be easier to remove, and then closed it all again. It wasn't that easy to close though. In the end, it actually sucked that I didn't film the whole process, since it turned out to be one of the most interesting things to repair from this entire build process. But well, I guess you learn things along the way. After having seen the stuck filament and also the failed print, I thought I had an idea of why this actually happened. The print looked very brittle. You would have flakes all over it. And also inside of the extrusion head you could see that it was all tangled up, so there was something wrong with the filament itself. This brand that I've been using actually had been giving me quite some issues in other printers as well. If you use the filament right after opening it, it was no issue at all. But after having it laying around for only like a week, the print quality decided to drop dramatically. So I restarted the print with a roll of Bambu filament, and it worked great. The print finished and the print quality is pretty good. Actually, let me show you. Alright, so with everything fixed, I actually have a banshee with some stringing in the end. But well, let's actually inspect it, and actually not too bad. I am quite happy with it after the fix. So my thing is, I think the filament was the big problem. Yeah, I have this one over here, the Bambu PLA Basic. Great stuff, basically. Well, I actually had this one from a local Dutch company. It is good, but as you saw, it was very brittle. I will show you the comparison soon, but this is actually not too bad. I am pleasantly surprised by the quality. Alright, so if you actually compare the print quality, this is the first Banshee from my old Ender without all of the mods. Actually, not that great. You see a lot of layer lines, but back in the day it was fine, good enough for me. Then you have the Bambu Lab. Pretty good. It has basically no stringing, just, yeah, perfect almost. And then you have the upgraded 3D, upgraded printer. It's actually good. It's not as good as the Bambu, but if you put these two next to each other, the improvements are very noticeable. And as you can see, print came out pretty well. I didn't dare to run it on high speeds, so it was very slow. This Banshee alone took 2 hours, but I think with a bit of tweaking, a better first layer, I can get this down to sub 1 hour, which is still quite slow as compared to the 15 minutes it would take on my Bambu Lab, but it's still something. The print quality is better than it was before, dramatically better. And that's what counts, especially if I want to make big projects or abrasive materials, where the Sprite extrusion could really show its power. Eventually, I actually want to tweak it to perfection, but for that I might want to do that on Clipper, since that's way easier than to do it on Marlin. Because right now my setup for programming is in another room than for the 3D printers, so having to run back and forth all the time just doesn't really work. Right now I decided just to stick with Marlin, because this video wasn't about fiddling around with the firmware. I just wanted to get something up and running, and after that I would actually create a second video about Clipper. So yes, this isn't really a finished video. As you can see, there are many things weren't yet done, like the HMI screen or some other features that we previously discussed. I decided just to split it up because my channel can really use more videos on it. It's quite empty. And I also need the printer to be running for another project that I have going. So I just decided to split it up into 2 videos. I hope that you guys don't mind, but I think it's a logical way to move forward with this. So only thing that's left to do now is just to go back and actually put on all of the decorative elements, like the drawer and other kinds of stuff. Eventually you will end up with a result like this. Now it's time to take a step back and look at the achievements from this project. Originally the plans were way more ambitious, but I had to split it up into 2 parts. But currently I can already say that the initial goal was a success. I have prevented my Ender from being forgotten, and it will see some work again. I've tried my best to separate functionality of both printers so they would have their own specialty. I knew I would never be able to beat the speed and precision of the Bambu lab, so made it more of an all-round beast, capable of printing larger objects out of more material. While it takes significantly longer, I can still use this printer when I have a lot of things to print. But the big question is, can I recommend it to everyone? Let's first actually do a price analysis. If we take a Ender 3 or Ender 3 Max, doesn't really matter for this purpose, we have an initial price of 270 euros, or a bit cheaper if you have a Ender 3. If you then take into account all of the upgrades, you will add another 180 euros, or if you take all of the upgrades, another 260 euros. So you then have a total of 450 euros if you don't do all of the upgrades, or if you do all of them, that includes Clipper and the ones that I haven't done in this video, you would have a total of 530 euros. If you then compare this to Bambu Lab P1S, which is only 500 euros. On the price side, it gets really close to Bambu Lab P1S. And in all fairness, the Bambu will remain the most useful. So if you want to get into 3D printing, the upgrade route isn't recommended. But if you already have a Ender 3 laying around somewhere, or manage to get it for super cheap, it would be worth spending money on for some upgrades. If I would recommend the most important upgrades I would make, it would definitely be the control board. The lower noise alone makes it worth it. The old-time coupling is also a very cheap upgrade that has a very big impact on the print quality. If you then want to go a bit further, then adding a dual Z-axis is also worth it. If you then want the direct drive extruder, you would also need the dual Z-axis, but then again you're basically doing the full upgrade that I have been doing. In the end, I'm just very glad I've been able to save a very good printer for the dump. It's gonna be seeing a lot more work now. For the keen-eyed, you might have also noticed that another printer had been sitting in the corner. During the filming of the video, I managed to get an old Ultimaker S2 for free. I wonder if I can actually save this one from the dead as well. Currently, I still lack one more printer. That's one to do multicolor printing. So perhaps, maybe another project might be on its way. But this video ends here. I hope that you guys enjoyed. Because this channel is still new and I'm figuring out in what direction I want to go, and even if I like making videos in the first place, leaving a comment is greatly appreciated. See you guys another day on another project.